red alert, that's the worst ever. Nobody's ever experienced these conditions before. I better pay attention. Maybe we need that sort of scale change to draw attention to the fact that climate change is making these high-end storms worse. Hurricane we had just last week in Jamaica, 185-mile-per-hour winds, that's pushing the limit of where you might want to put a Category 6 sort of rating. Climate change is making these most dangerous type of storms more common. We should definitely pay attention to what's going on. They're just going to do whatever helps get them elected, and that means pleasing their fossil fuel donors for the most part. So you heat up the ocean, you potentially make a hurricane stronger. We're going to see 9,000 deaths this year because of increased wildfire smoke from air pollution due to climate change. The past 20 years of hurricane science advancements have created a $5 billion savings per major hurricane.
All right. Hello, everyone. Welcome to another episode of Science Talk. I'm your host, Dr. Muhammad Ittifaq. In this episode, I'm joined by Dr. Jeff Masters. You have heard his name, hopefully, until now, or you have read one of his blogs, who has worked before as a hurricane scientist with NOAA, Hurricane Hunters from 1986 to 1990. And after a near fatal flight into Category 5 Hurricane Hugo, he left the Hurricane Hunters to pursue a safer passion. He has done a Ph.D. in air pollution meteorology, if I'm not wrong, from University of Michigan. And we're going to be spending some time today talking about hurricanes, climate change, and a little bit politics around it. As we all say, everything is politics these days, unfortunately. But Jeff, thank you so much for your time and welcome to Science Talk.
Happy to be here.
So let's talk. You've been doing this for a while now, right? So I just want to start us from what are some of the biggest myths or misconceptions about hurricanes?
Gosh. Well, one a good one is the Category 1, 2, 3, 4, 5 scale that we use for rating them. The Saffir-Simpson scale is adequate. It is not adequate in a lot of senses. That's a wind scale. So
Mhm.
it doesn't convey to you, for instance, how much rain a hurricane might drop, or it doesn't tell you what the storm surge might be. And those are the three main hazards of a hurricane. And really only one of them, the wind, is what is, acknowledged in the Saffir-Simpson scale. So you could get a very slow-moving Category 1 hurricane that could drop catastrophic amounts of rain, and that would not be reflected in the urgency in the warnings potentially. So we have to come up with a better scheme for doing these sorts of triple sorts of warnings. The Hurricane Center has already acknowledged this with the advent of a separate storm surge warning criteria they put out that is independent of the hurricane warnings that they put out. So they'll issue storm surge watches, storm surge warnings, in addition to hurricane watches and hurricane warnings. And then we have a separate sort of heavy rainfall sort of warnings that the regular weather service can issue when there's a hurricane. So you have to realize that if you've got a Cat 1 coming at you, that could be the worst storm you've ever seen if it's very slow moving and it's got a lot of rain with it. This happened in North Carolina in Hurricane Florence a few years ago. Cat 1 dropped catastrophic amounts of rain, 25 billion plus damage, and it was the heaviest rain ever experienced in North and South Carolina.
So if it's inadequate or not sufficient to do that, why are we still using it? Why haven't we developed something which is more, do all of this?
There's no perfect scale.
Mhm.
Sometimes I point to what the Europeans do. They have a yellow alert, an orange alert, and a red alert. That's pretty simple, and it gives you the idea that, well, if I'm seeing a red alert, that's the worst ever. Nobody's ever experienced these conditions before. I better pay attention. So maybe simplifying it that in that regard makes sense. But I wouldn't want to throw away the whole Saffir-Simpson scale at this point because people are used to it, and there is some advantage towards familiarity.
So about the misconceptions, just speaking of those right now, you have written, I was hearing from a lot of news and podcasts, the Weather Underground website, you wrote 3,000 blogs, which is a lot. How many times in the past or recent years you have addressed misconceptions about these events?
Not a whole lot. There are a lot of other hurricane scientists that go into that more than I do. One of the things I will talk about is, do we need a Category 6 rating for hurricanes? Because we are seeing an increase in the very high end hurricanes. The Category 5 scale cuts off at 156 mile per hour, yet that doesn't mean that a hurricane can't go much stronger than that. It's an open-ended scale, so if you've got winds of 215 miles per hour, which is a full, what is that, 55 mile per hour higher than a Cat 5, that's not acknowledged in the ratings. Maybe we need that sort of scale change to draw attention to the fact that climate change is making these high-end storms worse. But from a practical point of view, I don't think it makes sense to do it because you're already going to evacuate if there's a Cat 5 coming at you. If there's a Cat 6, are you going to change what you do? Probably not. So, from a strict warnings sort of standpoint, the National Hurricane Center feels no urgency to adopt a Category 6. But still, I think it would be valuable to at least call attention to the fact that, hey, if we were to update the Saffir-Simpson scale, I mean, every 25 or so miles per hour is a jump in category. So, for instance, this hurricane we had just last week in Jamaica, 185 mile per hour winds, that's pushing the limit of where you might want to put a Category 6 sort of rating. And that draws attention to, hey, climate change is making these most dangerous type of storms more common. We should definitely pay attention to what's going on.
So two things out of that, what you just said. We are going to spend some time on talking about climate change and hurricanes, but before we get to that, I want to ask because a lot of climate scientists believe that we should get rid of, more conservative estimates and we should have more high-end probabilities. So do you also see that in hurricanes that we should have more high-end probabilities instead of, giving them more conservative estimates?
It's not the averages, the change in averages that's going to hurt us when it comes to climate change. Sure, we've seen a 1.3 degrees Celsius increase in average temperature. That doesn't seem like a lot, and it isn't a lot in a lot of respects, but it's the extremes, that tail end, those most disruptive events for society, they've seen a big jump. And we should pay more attention to these high-end cases, to the things that, only occur once in 100 years or once in 1,000 years. Those are the ones that are going to be most damaging to society. And from a risk standpoint, we need to prepare for that sort of thing to happen because our infrastructure, for instance, in coastal areas, is built for 1 in 100 year storms. And if now that sort of storm is going to occur once every 20 years, which is going to be the case in a lot of like flood events, for instance, then we need to adapt. We need to be more resilient and invest in better coastal defenses, probably move people out of high risk areas. And certainly we need to stop building in floodplains, the 1 in 100 year floodplains. It's really insane to be building in there, and we're still doing that to a high degree.
So, US is a huge country, right? And different regions are prone to different things, like Midwest, more droughts, right? Or tornadoes, like Kansas, Oklahoma area. If you go east or west coast, there's like more wildfires in the west coast, and then there's hurricanes and tropical storms in the east coast. So how do we like kind of make create more resilient communities and how the US approach should be? I mean, it's a very big, broad question, but like each area is a very prone to something different, right? Which needs a different preparation. It needs a lot of resources and it requires a lot of coordination between different departments. So holistically, or like in overview, if we talk about these extreme weathers, either it's droughts or flooding or tropical storms or tornadoes or hurricanes, how should we be approaching? Because one of your TED Talks, you also talk about like maybe New York City should be doing something like Netherlands do, right? So, and I don't know if they have done it. I don't think so. But like, how do we move? Because I don't want to have a conversation which you had like 15, 20 years ago, and we're technically still there.
There need to be a lot of political changes, that's for sure. There have been proposals that at the federal level, there needs to be a chief resilience officer in the U.S., a presidentially appointed and somebody who advises the president on matters of adaptation, how we need to spend our money to adapt to climate change. And there's been far too little attention given to that aspect of climate change as far as funding goes in the US. When we do a big bill like we did with the Inflation Reduction Act, tens of billions of dollars towards climate change, most of that money went towards mitigation. That means, renewable energy, which is important, of course. We need to stop burning fossil fuels and putting so much CO2 in the air. But less than 10% of our efforts have gone towards adaptation, for preparing for the new climate, for doing this sort of managed retreat that has to happen, for some of these wildfire areas to be adopting new strategies to protect homes against wildfire. And certainly in the hurricane zones, you got to do something different. So this all needs to be coordinated and what should be done at the federal level. We need to be smart about spending our dollars. In particular, we got to get people out of floodplains. People are going to be running away from the coast in the numbers of tens of millions in the not too distant future, 10, 20, 30 years. There's a couple of good books in this I'd recommend, but we have to prioritize where it makes sense to spend the money to do managed retreat, to get people out of harm's way. The way we're doing it now is like we see in North Carolina. There have been 15 homes that simply plunged into the ocean over the
Yes,
past
I
year,
saw that video. That video
right?
went viral. Yeah.
Yeah, I mean, that's our attitude. You just let it go until it collapses. And that is simply a poor way to go. It's going to cost everybody more in terms of damage and lives lost than if we are proactive. I mean, every dollar spent on being proactive, it depends on the study you're looking at, saves at least $6 in costs. So that's what we need to do. Be proactive at a federal level, get a chief resilience officer to coordinate all this.
So, in your experience, we are not doing it because we don't see it as a threat. I mean, we meaning like a political class, or is it too much influence from fossil fuel industry, or is it like both? And there is a realization because you talked about Obama's speech in one of your interviews as well, that he eloquently said that he's going to do this and it's real, it's going to happen, and all that, but was not able to do much. So, if we don't have like kind of hope or some tangible actions coming from the leadership, how do we move forward?
It's hard. Vested interests are very powerful. They have a lot of money. You mentioned the fossil fuel industry. They are the greatest impediment to climate action of all kinds, both in terms of mitigation and in terms of adaptation. As far as adaptation goes, we're also running up against resistance from the building industry, the real estate industry. They are interested in maintaining the status quo, continuing to build like mad because that's where the profits are. Also, cities have a vested interest in keeping the status quo, developing as much as possible because that generates their tax revenue. If you start losing that tax revenue, then you don't have as much money to invest in climate adaptation. So the whole municipal bond market is geared this way too. Cities sell bonds to help finance their projects, and you can't get a good bond rating if you suddenly start doing managed retreat. So there's no incentive at all from these organizations or these entities to do adaptation. It really needs to be driven by a political sort of willpower to do it, some common sense, and I really don't have much hope that's going to happen. I think it's all just going to go the way we've been seeing it. Homes plunging into the sea is going to be how we adapt to climate change.
Yeah, I think more and more people I talk to, they are falling into that category because they have decades of experience looking at how we adapt to these things, and it's not the picture they're seeing in the future is not very hopeful that may be moving into the right direction. But before we get more into that, can we talk a little bit about Hurricane Melissa, which hit recently Jamaica and Cuba? And you talked about it at the yeah, it's a Yale Climate 360, right? You wrote a couple of articles. So
Yale Climate Connections is who I
yeah,
write for. That's separate from 360.
360, yes, yes.
They're similar.
Yeah, they are. They have a multiple, climate programs, so that sometimes it's confusing. But
Right.
yeah, so can you talk a little bit about the hurricane? And I've been hearing, and I think we're watching. It's like the strongest hit ever. Uh, that region, and is it like being more like normalized that like we're using these acronyms and these things to describe these storms of extreme weather? This is the strongest ever in the history of recorded history, and people say like, oh, maybe in the 1980s and then early 2000s and then again. what's uncommon about it? It's like it's becoming more a norm.
We have to understand that our records of accurate hurricane history don't go back very far. The advent of satellites in the 1970s is really when the good record starts. So we've got, 50-ish years of good data. There's only ever been one hurricane as strong to hit land in the Atlantic as Melissa, and that was back in 1935, before the satellite era, as it turns out. The Florida Keys got a 185 mile per hour hurricane. So this is a very rare sort of storm. We did have one hurricane in 1980, Allen, that got to 190 mile per hour winds, but Melissa's tied for number two for all time, and it may turn out in the post-analysis that it did get even stronger because the satellite estimates were way off the charts. I mean, they were saying this was a 215 mile per hour storm. The hurricane hunters got in there and found it wasn't. So, I would weight the hurricane hunter data more, but still, a lot of incredible stuff going on with that hurricane we've never seen before. In particular, two hurricane hunter flights had to abort their missions because the turbulence was so extreme, very dangerous to fly into one of these near Category 6 type of hurricanes.
And you've been to one of them, right?
I spent 4 years flying into hurricanes. I've been into two Category 5s, including the most recent one to level Jamaica, Hurricane Gilbert of 1988, which had 888 millibar pressure, 180 mile per hour winds. It was, on par with Melissa last year, but fortunately didn't hit Jamaica at that strength. And then you mentioned at the top of the show, yeah, I flew into Hurricane Hugo, Category 5 as well, back in 1989, and nearly didn't make it back from that flight.
And that I mean that could be scariest thing ever. Being stuck something like that. So 13 years ago, you gave a TED talk where you predicted nine biggest weather disasters in the next 30 years, right? So has anything changed since then? It's been almost half a time since you predicted those.
Yeah, that was interesting. I did that talk the year before Hurricane Sandy hit, and I said, a hurricane in New York City, that's one of the 10, $100 billion disasters that could potentially happen. And the next year, it came very close to a $100 billion disaster. So the other ones that I've talked about, fortunately, they haven't hit yet. But I gave them all less than 50% chance of happening in the next 30 years. You have to understand, if you look at the law of averages, something that has a 1 in 100 year recurrence interval has a 1% chance of happening in a given year. But if you integrate that over a 30-year period, that's a 26% chance. So if you
That's a
look
good
at,
chance, yeah.
yeah, kind of the longer, window, the life of a mortgage, for instance, is 30 years typically. If you've got a 1 in 100-year chance of getting one of these disasters, 26% chance in 30 years, that's pretty high.
Yeah.
So some of the odds of these disasters, I think, have gone up in my estimation. For instance, my number one concern is what's called the arc storm in California, which would be a $1 trillion flood. And there's actually been a case back in the 1860s where a rain event, were it to recur in the current climate, would cause $1 trillion disaster. And some of the research that's come out since I gave my talk has shown that this may be more like a 50-50 chance in the next 30 years. So a lot higher than we thought.
And-
Another thing that's
Mhm.
happened in the last 10 years or so is the sea level rise along the U.S. East Coast has really accelerated. It used to be like 3 millimeters a year. Now we're up at near 10 millimeters a year. So that really increases your odds of a storm surge disaster getting to be very, very expensive. So any hurricane that hits is going to be a greater chance of doing 100 billion in damage than I originally estimated. So those are a couple of cases there.
And in the same talk, you said, and I'm quoting, we don't know what climate change is going to do to
Hmm.
hurricanes. And I'm just going to ask you, after 13, 14 years, do we know now?
That is the $100 billion question, right? So, a couple things this year which were very, very interesting. We went the peak 6 or 7 weeks of hurricane season seeing basically no activity through mid-August through late September, almost nothing. That's the peak part of hurricane season. It was crazy to see almost no activity during that period. And that happened also a couple years ago. So, these forecasts of climate change causing increased Atlantic hurricane activity, what about that? But
Yeah.
then, okay, now look at how many Category 5 storms we had this year. We had three of them. We had five hurricanes, three of them Cat 5s. That's a 60% batting average. Never seen anything like that before. So both of these sort of events maybe fit in with what the future holds. The strongest storms are going to get stronger, but we may see fewer total storms. That's what the climate models are saying. Fewer total storms. The ones that we do see have a better chance of hitting Cat 5. So, yeah, that's good that we'll see fewer total storms, but what we really care about are those high-end storms. About, I think, 15% of all landfalls in the US are Cat 4 or Cat 5, yet they've done more than half of all the damage in history. So if you're going to boost your number of Cat 4s and Cat 5s by 50%, say, due to climate change, that's not good. Even if you reduce, your Cat 1s and your tropical storms hitting land, that's not going to help out at all. So we don't know what's going to happen.
Yeah.
I mean, maybe this is a bellwether of the future,
Mhm.
but another thing to consider is that we know that the El Nino La Nina cycle heavily affects Atlantic hurricane activity. And this year we were in the neutral phase, so it didn't really cause a big impact that we can figure out. But the climate models say we should be more El Nino-like. That tends to reduce hurricane activity. But the problem is that in the last 40 years, we've observed the reverse. The climate has tended to be more La Nina-like, which favors Atlantic hurricane activity. So this gives us a problem when making long-term climate change forecasts for hurricanes. The climate models say we should have a more El Nino-like climate. We're actually observing the reverse is happening. So are the climate models right or wrong, and why? Well, for now, we don't know the answer to that problem. And so we really can't believe the long-term forecast of Atlantic hurricane activity because the models are not getting this fundamental issue right about whether it's going to be more La Nina-like or El Nino-like.
Yeah, and I think one of the other things related to that, I'm just gonna add to that, like when I talk with a lot of climate scientists, this like it actually generates more questions than it answers us because there's a lot of uncertainties and a lot of data points, and it's changing so rapidly, But that's the thing, climate denialists, use that. Oh yeah, you see, they don't know what they're talking about. They don't but themselves know, it's gonna change or not, but they're just asking us to change our lifestyle. So. Would you add a new city into that list now, or because I'm just really curious about that because recent climate like the mayoral race in New York City, I've been watching closely, and a lot of people for a lot of different reasons. No one in those debates asked any candidate about climate change or hurricanes or, weather
Hmm.
patterns and how New York City is going to be, preparing in next 10, 20 years or your mayoralship would do that. Nobody's talking, not even mainstream media where they spend 2 hours debating these candidates, they don't talk about that.
Yeah, it's going to be something we're going to be talking about pretty darn soon in the coming 10, 20 years, I'm sure. Uh, I think I put in my list of the 10 potential $100 billion disasters, I put New York City, Miami, Houston, Tampa, and New Orleans. I think that pretty much covers it for $100 billion disasters. Um, yeah, I don't have any new
You,
sorts of items to put on there. I think I had it pretty well pegged. That's just for the US. I don't know outside the US very well. I'm sure there's some places in China that could get a typhoon. That would be of great concern. I know, for instance, Shanghai is very low lying, and that's a critical hub for global economic purposes. Also, the Pearl River Delta in China, very heavily developed, also very low lying, vulnerable to sea level rise. So, there are some other international locations that should be added to the list, but I don't think I know enough about the specific risks there to add or subtract anything.
So, over the last, 2 decades or 3 decades, the technology have changed substantially, over the years. And like when you started back in the days and now you see, do you see any observable or noticeable like kind of changes? You see like, oh, we were not able to do this and now we are able to do this because of technology, or how much it has helped us knowing these, even though we know there's a lot of uncertainties, but still, to what extent would you say that it has become a little bit more easier compared in the past to predict or project these extreme weather patterns?
Our best model this year for predicting hurricane tracks was a new AI model developed by Google called DeepMind.
Hmm.
It's just very exciting to see this new model come on board. And every single discussion the Hurricane Center put out said, well, the DeepMind says this. And that's really extraordinary. I've never seen a new model come online in such a proficient fashion and be able to greatly improve things. I mean, the Google DeepMind forecast beat the National Hurricane Center track forecast this year. It did not for intensity forecast, but still, that's a huge bonus. And certainly developing better AI models is going to be an exciting area where we're going to do better in the coming years. It's concerning to me that in the US, we're spending less money to fund hurricane research, though. Huge cuts going on in NOAA right now. One of the biggest cuts I saw recently, as far as hurricanes go, is the National Science Foundation's AI modeling department was basically eliminated or is proposed to be eliminated. The NOAA's Hurricane Research Division has been proposed to be eliminated. So, yeah, this new technology is great, but with the current budget crunch mode going on in Washington, this technology is not going to do us any good if we're not going to invest in it.
Yeah, but like on the other hand, when you see these tech bros meeting with the current administration, throwing billions of dollars or hundreds of billions of dollars into different models, is it more of a vested interest for these companies and less of, kind of improving the lives at large? Because one of the recent viral news was 14,000 layoffs from Amazon, or there are like big billboards, don't hire people, AI would do the job, right? So,
Hmm.
on the one hand, they are making more investments in AI. On the other hand, we're cutting the funding, which can be super helpful, saving us billions of dollars in damages from these hurricanes.
We have to understand that every weather model requires good data to go in it. And if you're not collecting good data, like we are currently not in the
Yeah.
US compared to previous years, your AI models are not going to be helpful at all. You've got to spend the money to take the weather observations from balloons, which have been cut by about 20% in the past year. Satellites, they've seen cuts. Out over the ocean, your buoys, or in the case of hurricanes, we had robot sail drones that went into hurricanes. We didn't have those this year because they got cut. All these things need to be funded fully in order to make a good forecast. And that's a big concern. You were alluding to saving billions of dollars. There was a study done last year by the NBER, nonpartisan government organization, showing that the past 20 years of hurricane science advancements have created a $5 billion savings per major hurricane hitting the US. And NOAA's entire budget is just over 6 billion. So we've saved we've had 5 years in a row with major hurricanes hitting the US. So 10 major hurricanes multiplied by 5 billion saved per hurricanes. That's a $50 billion savings just in the last 5 years because of advancements in hurricane science. Far more money was saved than we've spent on all of NOAA. So it's a real huge cost benefit ratio to continuing to fund these efforts.
And it's very sad and unfortunate to see that many, these administration don't see that as. But in your own experience, looking at that, you have generated, millions of audience out of that blog. Do you like have some discussions with policymakers ever, and like what kind of concerns they show, or like what do you tell them when Did you ever meet them, or like do they ask questions, or do you communicate with them ever in the last 10, 20 years, other than like, at the more public outreach work you've been doing?
I've discovered something which shouldn't be a big surprise to people, but when you donate money to political candidates, they want your opinion.
Yes.
So I live here in Michigan, and I had the fortune of being a co-owner of my company, Weather Underground, when we sold to the Weather Channel back in 2012. So I got quite a bit of money from that. So I decided to try and, influence politicians and see where that took me, because I was frustrated with the pace of what was going on in the climate change world. So yeah, all of my local politicians and both at the Senate level, the House of Representatives, and then at the local House and local Senate I've talked to over the years, both Democrat and Republican, primarily Democrat because they're more receptive. And the way have been going at it is to say, okay, here's how climate change is affecting my state. And I'll go get all the numbers, for their particular district. And that's a really good way to, get their attention. They understand what's going on. Everybody's interested in the weather. Even the Republicans, politicians I've talked to are very receptive to, oh, okay, wow, the weather is changing here. How about that? Of course, I'm not going to do anything about it, but at least it's good that they understand what is going on. I mean, these are smart people for the most part, these politicians. But, you know, whatever you can do
Smart
to
in I
educate
mean,
them is good.
smart in a what way? Getting reelected?
I just mean they understand the science if it's presented to them. I mean, they know, what they can do politically is a lot different from what they should do. So at least knowing what they should do is good to have happen.
Or what will they do? The will. There's a can and should and will. So,
Yeah, I mean, they're just going to do whatever helps get them elected, and that means pleasing their fossil fuel donors for the most part. So
which is sad.
I don't know how to get around that. It's a tough one.
I don't think, and like, I think many of us do know that because the money speaks louder than anything else in the US political system. It's a very open secret. So in your own observation or experience, do you think like in the beginning when NOAA was established, looking at its aims and scopes and like why do we need this and why do we need this to fund, do you think that motivation has gone down, like in terms of what this division is for, or like what it can do, or like should do, all of that, or like what has changed fundamentally, other than like politically? Like, I mean, we know like politics is big, but other than politically, what has gone like because you were talking a little bit about the research, they don't have a data, they're not collecting data, so it means there's a lot of other non-profits or university centers which are collecting data, but their capacity is also limited because they also rely on funds from NSF and NIH or other grant agencies other than some foundations or other things. But what has gone down or wrong in terms of why we started as, nation or a country to not increasing the budget while we're increasing the budget of so many other agencies or institutions or departments while we're not thinking much about this.
There's this fantasy that the private sector can come in and do the job better than the public sector.
Oh,
You see it in Project 25, the document that's guiding a lot of the policy going on these days. It says that the National Weather Service and NOAA should be broken apart because private industry can do the job better. And to prove their case, they cite a press release from the private company AccuWeather showing that their forecasts were better than the National Weather Service. That was not a scientific study, that was a press release. So the private sector cannot do the job better than the Weather Service. They can do some things better. They can augment what's going on there. There are private companies with their own satellites now, their own weather satellites. There's upper air balloon observations being done by a private satellite, which NOAA is now sucking in to help the lack of balloon data that they are experiencing. So the private sector can have a role in helping things out, but it can't replace the Weather Service. Certainly, the warning capability that the Weather Service has is going to be impossible to reproduce. The Doppler radar network is huge and hard to maintain and very expensive. And it's a big concern of mine, in particular with the funding to the Weather Service. The radar technicians that maintain those Doppler radars are being lost, a lot of them. So you could have a Doppler radar fail during the heart of severe weather season and not have anybody there to fix it, resulting in a tornado hitting a major city that is essentially unwarned. So that's where the misconception lies that the private industry can come in. The magic of the marketplace will come, make things right. Well, it would be pretty magical to have NOAA cut like we've seen, just chopped without any intelligence or rhyme or reason, and have the private sector move in to make things better. That is magic. That's not going to happen. It has to be a carefully planned process spread out over years. I mean, in the 1990s, the Weather Service was downsized 9%, and it was carefully planned. They did this with all the stakeholders involved. They made sure to do it so that you didn't lose, a critical mass of leadership in one location and not in another. And at the end of the process, we had a stronger weather service. But the Dodge cuts that we saw this year, you know, hacking away randomly, essentially, all these people, that's not a very intelligent way to reduce your workforce and expect a orderly transition to a new reality dominated by private industry.
Yeah.
Not going to work.
Yeah, I think it's a civics 101 to see like when we bring a private company, they have their vested interest at the forefront and then they think about anything else, right? And it's not hard to understand. But overall, like one of the biggest things, because if we talk about like, yeah, climate is maybe complex, but if you try to understand, it's not that much complex to see like what we are doing as humans and our activities and how we, kind of producing more, eating more, shopping more, like doing more things, and then that's gonna like have more greenhouse gases in the atmosphere, and then that's gonna like warm the oceans and things like that. But like, what is the connection? I mean, it's obvious to us, but maybe for the larger audience, if you can talk a little bit about how these extreme weathers are becoming more extreme because of the climate change.
Pretty much all kinds of extreme weather, except for cold, become more extreme with climate change. Certainly, heat, that's an obvious one. I mean, heat waves are going to be more intense and longer lasting potentially. Drought, that seems like another obvious one. I mean, if you're going to be hotter, you're going to dry out the vegetation more, and thus your droughts will be more intense. And following from that is wildfires, obviously, are going to be more intense because now you have drier vegetation because it's hotter. So, yeah, they'll burn more. But what a lot of people don't understand is with heavy rainfall events also increasing, when it does happen to be wet enough to rain, then you've got more moisture in the atmosphere. A warmer atmosphere holds more water vapor. So now you've got the potential for a stronger heavy precipitation event just when everything else happens to line up. And hurricanes, well, they're heat engines. They take heat from the ocean, convert it to kinetic energy with their winds. So you heat up the ocean, you potentially make a hurricane stronger. So all these things get more intense with climate change. And what's more, you can get a whiplash effect. So when it is dry enough to have a drought, you're going to have a more intense drought. But then when it does cycle over towards you're getting a jet stream pattern where now you're getting rainfall events, all those heavy rainfall events are going to be more intense. And that's not necessarily very good to relieve your drought. Heavy rains tend to run off quicker, and plus, of course, they cause floods.
Yeah.
So you're getting the worst of all possible worlds. You're getting a more extreme hydrological cycle, as we call it, more intense droughts, and then relieved by more intense rainfall events.
So, just two more questions around that before we kind of ask you last question, which I ask everybody. So you got your doctorate, right? And your PhD in is it pollution meteorology? What is that? And like, did it change anything how you do the work after you get your PhD?
I've been using that skill
Mhm.
A lot the last couple of years personally, living here in the Midwest because of all the wildfire smoke episodes that have been going on. I never thought that a big impact of climate change on my life was going to be wildfire smoke. But here in the summers now, we're getting regularly,
Yeah.
I got to go wear a mask to go outside, or I start coughing. I got to cancel my summer vacation because I can't go to Upper Michigan to go camping because the visibility is 3 miles in smoke. So I'm really learning about how we can forecast these events better. And I did a post last year, which I recommend everyone read, called 15 tools for wildfire smoke forecast. And it's tough. It's very hard to make a good wildfire smoke forecast because you not only have to get the weather right, now you've got to get the emissions right too. And if it's cloudy over where the fire is burning, the satellite can't see down to tell you how bad the fire is. You need to know what the vegetation type is, the winds, to how fast the fire is going to spread. So very, very complex. I kind of liken what's going on now with wildfire smoke forecast to what numerical weather forecasting was like 40 years ago. We were just getting started. We had these new models that just came out. We were learning how to use them. They were new, not very good, but they're getting better. So yeah, that's one place where my expertise in air pollution modeling has been very helpful, understanding these wildfire smoke forecast models and telling people, how they can use them, because that's going to be very important for everyone, worldwide,
Absolutely,
well,
absolutely. No,
certainly in the US.
yeah, I remember like maybe 2 summers ago, I was landing in Charlottesville Airport, and there was a wildfires in Virginia, and we feel it in the airplane, and that was like very bad experience for a few
Hmm.
minutes. They took a few rounds before they landed because there was a risk. But like I also want to ask something else. Like I try not to talk much about politics, talk more about the substance. Give people ideas about these climate, energy, hurricanes, and extreme weathers. But like do you think is it possible, or like what are some of the ways we should be talking about these issues without bringing too much politics into it, even though we all of us know that at the end it ties back to politics. But I want to talk more about these issues without bringing politics too much into it.
Catherine Hayhoe, who's a climate scientist that's
Yeah.
very active in social media, talks about what are the things we can do personally to help out with climate change. And the number one thing is to talk about it, to
Yes.
bring awareness to other people, to discuss how climate change is affecting our lives. This thing I'm talking about with wildfire smoke, that's one we can all relate to. And also to educate yourself, learn more about climate and climate change, how things are moving forward. Certainly getting active in a local group would be a good way to go. Eating lower on the food chain is a good thing to do. Less meat is good for the planet and good for your health and cheaper on the wallet. So why not do all those things? So
Yeah.
I recommend that you go check out Catherine Hayhoe, some of the stuff she's done. She's written a great book called Saving Us, which I highly recommend to your audience.
Yeah, thank you. And I think when I talked last week with Dana Fisher, Saving Ourselves, she wrote that book, and she also talked about like how community actions and small, steps can help us instead of looking at the politicians. So last question before I let you go, is that what is something, this question I ask everybody, what is something we are not talking and we should be spending more time talking about when it comes to climate change and extreme weather patterns?
I think it's air pollution because air pollution from burning fossil fuels kills something like 8 million people in the US each year.
Wow.
I'm sorry, 100,000 people in the US, 8 million people globally. So just stopping burning fossil fuel is going to save all those lives and 3% of US GDP for free.
Yeah.
So we don't even have to talk about climate change. It makes sense to stop burning fossil fuels just for reducing air pollution. And air pollution in the US, we're getting 9 or so thousand deaths a year from increased wildfire smoke, which is climate change related. So air pollution is a huge thing that's overlooked right now. I mean, you get so much press was given to these Texas floods this year, rightfully so, that killed 140 people. But hey, we're going to see 9,000 deaths this year because of increased wildfire smoke from air pollution due to climate change. So why aren't we talking about that?
Yeah.
It's kind of invisible because you got to do these excess mortality studies to see it in a lot of cases. But that's what we should be talking about is more about air pollution, more about wildfire smoke and the impact it's going to have on health going forward.
Yeah, thank you. Thank you so much for your time. And I agree. I'm from Lahore, Pakistan, and we last year the AQI was 1175. And right now it's almost 600. They're using those smoking guns and anti-smoke guns and all that
Hmm.
temporary issues, but like temporary solutions. But the AQI in some of the cities were over 2000. So you can't imagine living or breathing in that environment or that bad air quality. And that's definitely one of the things I think we should be spending more time. Thank you so much, Dr. Jeff, for your time. I appreciate that.